Uh-huh. Okay. So let's please welcome Giouli Korobili.
Thank you very much. Good afternoon to everyone. Thank you very much for the invitation. This is a presentation about, on Seneca's natural questions and the question of whether, in his view, the heavenly bodies can actually nourish themselves. From early antiquity onwards, almost every aspect of life, such as hospitality towards friends or strangers, the exchange of gifts, sacrifices to the gods, or victory in battle, was most closely connected with symposia and with dining. This led some philosophers to warn against the dangers attending the immoderate consumption of food and drink, which might eventually affect the soul. Plato, for instance, treats the body as a source of evil from which the soul must be purified and liberated. To that end, the soul must not yield to, but rather resist the affections of the body through abstaining from the so-called pleasures related to food and drink, from sexual pleasures, and from the pleasures of ornament. Yet, in the 5th and 4th centuries BC, nutrition began to be understood as more than just the activity of consuming food and drink. Doctors and natural philosophers came to regard nutrition as the first and most basic faculty of the ensouled body, by which it was enabled to preserve its own being, to grow and to function properly. Aristotle, looking at nutrition from a biological point of view, treated nourishment as absolutely necessary and insisted that no physiological function can be fulfilled if the body is not properly nourished. Of the physical functions, nutrition is the first to take place when a living body comes into being. It thereby inaugurates the joining of the material body with the spiritual soul. Unlike Plato, Aristotle did not define a distinct place in the body for the nutritive part of the soul, but located it with the other functions of the soul in the heart. For Galen too, nutrition is a vital function. Sustenance, together with growth and generation, comprise the natural faculties, which remain vital powers until the body completes its development. After that, these faculties turn out to be handmaids of the psychic ones, such as sensation and voluntary movement, exercised by the brain. Nutrition was directly connected to health, one of the highest goods already in antiquity. Around the time of Hippocrates, ancient physicians were concerned with the effects of the quality and quantity of nutriments on human health. They believed that nutrition exerts a direct and significant impact upon the organism's internal balance. They developed elaborate systems of dietetic rules in order to regulate people's health. These rules needed to be flexible, as they had to be adjusted all the time in accordance with variations in bodily conditions, season, climate, and other environmental factors. Dietetics included not only nutrition, but also exercise, bathing, sleep, massage, sexual activity, and more. It was believed that by way of a healthy lifestyle, one could maintain and improve the quality of everyday life and thereby obtain longevity. On the other hand, malnutrition could lead to bodily illness. Hence, nutriment was also regarded as a natural medicine used both for treatment and prevention of disease. Even if the ancients were unaware of notions such as energy and calories, they certainly realized the importance of nutrition to health. Nutrition also had to be adjusted according to life stage. Many ancient authors speak of an organism's life cycle consisting of 4 stages: conception, growth, flourish, and decline, which are the natural phases of its development. At each of these stages, the presence of the soul inside the body is beyond doubt. However, vital factors such as internal heat and pneuma require a stable process of nutrition, with the kind and amount of food being adjusted according to the person's needs, which in turn are dependent on one's age and constitution. In this talk, I would like to focus on Seneca, the Roman Stoic philosopher, politician, and tragedian who lived the 1st century CE, and examine his views about nourishment, in particular of the heavenly bodies. The main text to use will be his Natural Questions, a text rather neglected in modern literature in comparison to Seneca's other works which survive today. The heavenly bodies are actually nourished by the earth in his view. This view has its origins in mythological and cosmological thought of the past. Change slides, please. The several aspects of which cannot, unfortunately, be now presented due to time restrictions. But Seneca undertakes to construct a rational argument, please change slide, and present a theory of nutrition of the celestial sphere which could suit a lecture on natural philosophy. This argument is founded on the assumption of a macrocosm-microcosm analogy, according to which the celestial sphere is a natural body and it needs nourishment, just like our own bodies need food and drink to survive and remain strong and healthy. And I quote, please change slide. I think that the earth is controlled by nature and on the model of our own bodies, in which there are both veins and arteries. The former are receptacles for blood, the latter for breath. In the earth too, there are some passages through which water runs, others through which breath does. And nature has created such a resemblance to the human body that our ancestors too spoke of veins of water. And Seneca continues in chapter 15 with the text that follows that you don't have in your PowerPoint in the presentation. Now, in us, there is not just blood, but many kinds of fluid, some essential, some corrupted, and rather too thick. In the head, there is the brain, mucus, saliva, and tears. In the bones, marrow, and something added to the joints as a kind of lubricant so that they can bend more readily. In just the same way in the earth as well, there are several kinds of fluid, some that harden when fully developed. From them comes the entire harvest of metals, from which greed seeks out gold and silver, and substances that turn from liquid to stone, and some that are formed from the decay of earth and moisture, such as bitumen and other things of that sort. This is the explanation for the kinds of water that come into being according to the law and will of nature. End quote. The comparison with the living body provides a vivid description of how Seneca understood the interconnected processes below and above the surface of the earth, and guides the reader to conceptualize hydrological and geological activity by making valuable use of physiological examples. Veins and arteries, various organic containers, health and disease. Instead of being thought as chaotic, the subterranean region is presented here as a structured place with myriad cavities, some containing water and others air, just like veins in our body contain blood, while arteries contain breath. Seneca goes on to enumerate brain, mucus, saliva, tears, marrow, and some sort of synovial fluid as bodily fluids which are to be found in different organic containers, head, including mouth and eyes and bones. His ultimate purpose is to emphasize multiplicity, variety, and functional uniqueness as characteristic in living bodies and the natural cavities. Each one of these fluid materials plays a distinct role within their respective containers, and for this reason, it gives its container a special identity. Tears are produced only in the eyes and for a particular function, and so does marrow in the bones. According to Seneca, Book 6, Chapter 16, the earth includes in its cavities life-giving breath that is vigorous and sustains everything. If this was not the case, how would have been it possible to instill breath into all those trees and plants that have no other source of life? How could it nourish all the different kinds of roots that go down into it in different ways, some growing near the surface, others sent deeper down, unless it contained a lot of soil to produce so many varied plants and make them grow as they breathe and feed on it? Yet, the earth does not nourish only plants and trees, according to Seneca, but everything in the world, including the heavenly bodies. Quote, "The entire heaven, surrounded by the fiery ether, the highest part of the world, all these stars whose number cannot be reckoned, all this host of heavenly bodies, and to omit the others, the sun, which orbits so close to us, several times larger than the entire circumference of the earth, all these draw their nourishment from the earth and share it among themselves, and are obviously sustained by nothing other than the earth's exhalation. This is their nourishment, this is their food. Now, the earth could not nurture so many things so much larger than itself if it were not full of soul, which it gives off from every part of itself day and night. It must be the case that it has plenty left over, when so much is demanded and taken from it. To be sure, what is emitted is created as required, for it would not have a constant supply of breath sufficient for all those heavenly bodies unless the elements moved in a cycle and were transformed into one another, but nevertheless the earth must be full and overflowing and must bring breath out from its storehouse." End quote. The earth is portrayed by Seneca as an infinite source of nourishment for living things, the sun and the stars. Seneca uses the language of the biological process of digestion and assimilation of food. The earth produces exhalations, airy emissions, which are distributed to the celestial bodies, and the production is regulated according to their needs. The whole process is continuous. The earth produces day and night. Does this mean that supply and demand between the earth and the celestial bodies are synchronous? This would indicate a great difference between the diet of living bodies and the diet of celestial bodies. Is consumption the only concern of the celestial bodies? If so, how can they enjoy the prestigious status that almost all ancient thinkers claim, since they are almost divine and eternal, and do not have to worry about anything? In other passages, Seneca offers more detail. Although the day and night motif recurs in such contexts, as we will see later, the process of supply and demand of nutriment and emissions is asynchronous. The sun does not consume day and night, although the Earth constantly produces exhalations. Quote, so how is the kind of air current that the Greeks call enkolpias produced? The emissions given off by marshes and rivers, they are both abundant and continuous, by day nourish the sun, but at night they are not used up, and when enclosed by mountains, they collect in one spot. When they have filled it and no longer have enough room, they are forced to go somewhere and they advance in one direction. This is a wind. End quote. The sun's daily nutrition is sufficient for its maintenance, as is normally the case with the human biological clock. The air emissions that the sun does not use for its nourishment create winds. The exhalations produced by the Earth at night are not in vain, but once trapped beneath the Earth's surface and increasing in volume, they are pushed outwards, producing what the Greeks called enkolpias, winds that arise in gulfs. The transition from day to night is not the only temporal distinction that affects the nutrition of these bodies. Quote, in certain months, the heavenly bodies are more oppressive and drain moisture from the rivers. When they have moved further away, they consume and draw up less. Thus, what used to contribute to expenditure contributes to growth, end quote. And the second passage, quote, in summer, the heat of the day continues after sunset and lasts for most of the night. This draws out the emerging exhalations and extracts more vigorously what is usually given off spontaneously. But then it does not have enough strength to consume what it has drawn out, end quote. With these passages, Seneca reveals two new aspects of the nutrition of the heavenly bodies that relate to time. The first is their distance from their food source. Depending on their celestial location, the celestial bodies absorb more or less food over the course of the year. The second aspect relates to the heat of the sun. In the summer months, the heat is stronger and forces a larger volume of exhalations to rise, as this process continues even after sunset. This does not necessarily mean that celestial bodies consume more in summer. However, it does suggest that environmental production is more intense during this time, more exhalations, more heat, and this leads us to our final passage for today. Quote, from the earth, nourishment is apportioned to all the animals, all the plants, all the heavenly bodies. From it, provision is made for each thing individually and for the world itself with all its numerous demands. It produces nourishment for all those heavenly bodies which are so energetic, so eager by day and night in both their activity and their feeding. All things by nature size enough for their own nourishment, and the world has appropriated as much as it needed for eternity. I shall offer you a tiny illustration of this important fact. Eggs contain enough liquid to generate the creature that will emerge. End quote. This passage demonstrates the ancient belief that the earth must work hard and intensely to meet the world's various demands. From this belief, it becomes clear that nutrition is not the only activity of the heavenly bodies. Rather, it suggests that nutrition supports and encourages their unceasing activity, with hunger being a strong indication of the activity actually taking place. Energy and hunger mean that these bodies are in good condition, which is due to adequate nutrition. The comparison with the egg which contains everything necessary for an animal's nutrition and growth, vividly depicts the world as an egg that is self-sufficient and constantly changing. The body of the cosmos exists, grows, and performs its various functions in the same way as living bodies do. Given that time is seen both as a measure and as a determining factor, we can identify various synchronicities and asynchronicities in the process of development and change of a living body. 1. Nutrition is understood and presented as a process of receiving, processing, and recycling the sources available. 2. Energy and hunger imply continuous and ceaseless activity of the body. And 3. By implication, health is conceived of as stability, while disease as instability, affecting all living things as well as the heavenly bodies. Thank you, and I give the floor now to Susanne.
Thank you very much, and sorry for the switching at the beginning because there was an issue with the mouse, but now I will continue with what has been shown accidentally at the beginning already with the astronomical commentary, with a commentary from the point of view of modern science on Seneca's view of the nourishing of the celestial bodies. So celestial bodies today are a matter of astronomy, but Seneca also speaks about the celestial sphere, which is a sphere surrounding us, and the sphere he considers as similar to a body as a human body. Actually, the celestial sphere for us today is rather a projection screen and not a body. We still use the celestial sphere in modern astronomy, but rather as a sort of coordinate system or frame of reference, not only mathematical coordinate systems, but also frames of reference that evolved over several millennia of human cultural development emerged, for instance, in terms of constellations. Constellations are a frame of reference that help astronomers to talk about a specific object, like this and that planet happened to be in a specific or next to a specific star or a specific constellation or a specific pattern in the sky. In our Greco-Roman astronomical culture, we use constellations that are made out of stars, like bright dots in the sky, forming a pattern that looks like a specific deity or anything, or an animal. But other cultures, like many cultures on the southern hemisphere, like the Incas, several Australian Aboriginal cultures or South African cultures, consider the clouds that we call the Milky Way also as a resource of images in the sky. Some use the bright clouds of the Milky Way, some use the dark clouds of the Milky Way. For instance, what we can see here is the head of a dark constellation that is called the celestial emu or a crocodile in Aboriginal cultures, but you can also use these dark clouds in the Milky Way to project a celestial body, a sort of something like a human being into these dark clouds. So that is what we use the celestial sphere for, as a frame of reference, speaking of this and that object close to, say, this dark thing that looks like the head of a figure. This is what we typically teach in modern planetariums, where we use the celestial sphere as a projection screen to project other figures, images on the stars and patterns in the Milky Way and so on. Seneca extends this sort of analogy in order to observe the Earth itself. He, for instance, observes when we go into the Earth underground, we find caves, we find niches in the Earth, in underground worlds, but we also find underground rivers, underground lakes, and so on. And we can walk these underground rivers, maybe with the feet in the river, but still breathing the air. And this is what he finds or considers an analogy to our own human body, where micro organisms go through the veins as the water and the blood and the air that we breathe runs through these veins in our human body, as we find it underground in a more in a bigger scale, so to speak. And we can walk these underground paths like microorganisms can run these veins inside our human bodies. So this is an analogy that he finds. So inside the Earth, it seems to look as in the human body. That is why he thinks all the celestial bodies that we observe and we cannot touch, in contrast to the Earth, probably are built similarly. Here he uses also an argument of analogy. And he follows Aristotle, who also said we can observe that the sun and the moon are bodies, are 3D objects, are spheres, and the whole sky is a sphere. So everything is spherical in the cosmos. So probably the planets that appear as dots in the sky are also spheres, and also the stars that appear as dots in the sky are spheres. And all these little tiny spheres in the night sky, they behave similar than the Earth. So as we find underground veins of water and air inside the Earth, probably all the other celestial bodies also have their own veins that are filled with water and air. He says that these other objects may be bigger, larger than the Earth. And in particular, he says that the sun is more than double the circumference of the Earth, which is right, actually, because the sun indeed is spherical and is more than double the size of the Earth. And although he didn't know Uranus and Neptune, but all the other planets in the solar system were known in antiquity, and they are indeed all spheres or almost spherical. What he didn't know is that all these objects are much further away than anybody could guess in antiquity. So throughout antiquity, everybody underestimated the distance of their objects, and that is why they also underestimated their sizes. For instance, the sun, yes, is more than double the circumference of the Earth, but it is actually 109, 110 times the circumference of the Earth. It's much bigger than they have ever imagined. Also, today we, of course, know that it is not the Earth that is sort of nourishing the sun, but actually it's the other way around. But this is what, of course, Seneca could not know. And in his worldview, in his way of explaining how the cosmos works, everything sort of makes sense in this analogy to compare it to the human body. So he says we, as human bodies, we breathe, we sort of breathe in the air and then breathe out some other air. And that is why the Earth does something similar, and this produces the fog and the mist and also the clouds high up in the atmosphere of the Earth. And then these sorts of exhalation of the Earth are eaten by the sun, and the sun actually eats the fog in the morning. You can observe it when you have fog in the morning and then the sun rises, and when the sun gets stronger and stronger, it seems to sort of melt away all the fog. And he uses this analogy and says the sun obviously does this, and that is why all the other celestial bodies do something similar. And then he says wind occurs because the sun because the stars do not eat as much as the sun. So during the night, all the fog that is produced doesn't or is not eaten up. And that is why during the night there is a high there. Well, during the night, the material that is produced during the night causes a higher pressure, and this causes the wind during the daytime and in the morning. He correctly observes that there are several wind patterns that are connected to the sun. What he observes, what he seems to explain here, that the high pressure is caused during the night because the stars and the planets do not eat as much as the sun does, is certainly not the case, but still there are wind patterns that depend on the daytime or nighttime, or that occur differently in the day and the night, like the monsoon, which is a wind that balances the pressure of the air over the water and over the land, the continent and the ocean, for instance. It's stronger in East Asia than it is in other regions of the Earth, but there are these wind patterns that balance the different sorts of pressure of the air during night and daytime. There are other more global wind patterns, which you can see here. This is from, say, secondary school teaching devices, applications developed for America. That is why that it is labeled in English. But here you can clearly see that geology divides the sort of regions of the atmosphere of the Earth according to their distance from the equator, and there are indeed wind patterns that are in certain specific regions of the Earth. For instance, there is a specific wind pattern around the equator. So the sun standing above the equator, making all the moisture, all the humidity of the tropical rainforest going upwards and making clouds, producing clouds there. Then they, in that region, they have a daily rain in the afternoon, but also some of this causes a higher pressure here in the upper atmosphere, and some of the air with the moisture goes left and right because it cannot go down because more moisture and air is coming upwards. So the air has to go left and right, which is north and southwards. And then it is cooling down because it's not directly under the sun anymore. So it's cooling down and falling down towards the Earth, the surface of the Earth, above the tropical circles. And then we have a wind from the tropical circles towards the equator, which is called the trade winds, or in German, the Passat. And this is a known pattern. And of course, it is in this ideal scenario, we have the sun directly above the equator, but everybody knows that during northern summer, now, for instance, in May, the sun is not directly above the equator, but is further north. And for instance, in June, it will be exactly above the northern tropical circle, which means that this whole system, this system of wind circulation, of air circulation, will follow the sun northwards, will move this way. So this gap here will be further north and will squeeze together the northernmost wind cells, the polar and the mid-European wind cell, squeeze them together, and the South European, North African region, Mediterranean region will be dominated by the wind cell of the trade winds and not by the Central European wind cell anymore. The same similarly happens in northern winter at the southern hemisphere, and so the wind cells here will be stretched because the whole system will move southwards. So Seneca is absolutely right that there are specific wind patterns that are observable only in specific months, that they depend on the months of the year or the daylight period, how long the sun is above the local horizon, or something like that. So this observation is correct, although his explanation might be not correct in our modern view. He also speaks about these exhalations of the Earth. And of course, he is not right that this has anything to do with the month and with the trade wind patterns and so on. But still, let's trace back this idea, because Seneca in this case follows Aristotle, and Aristotle said that exhalations of the Earth also may occasionally burn in the atmosphere, and then this will form comets. 4 years ago, we had a very prominent comet in the summer sky. It occurred in May 2020. The comet Neowise was clearly observable for the naked eye, and also next to city lights, as it is seen here on this photograph. And you can see that the sky is already a little bit reddish at the far northeastern horizon. So here we see that the comet must have been really bright. It's a burning flame in the sky, so to speak. I mean, in their point of view. Today we know that comets are much further away and not part of the atmosphere of the Earth, but for them it occurred as if there were exhalations, burning exhalations of the Earth. So a comet, they thought, might nourish the sun. As we saw here, it is visible in twilight, so it's very bright. It's close to the sun because the sun already illuminates the sky. And indeed, modern space telescopes also observe that sometimes, occasionally, comets may approach the sun and even fall into the sun. So what they could observe in antiquity was that comets sort of approach the sun and sometimes occur on the other side of the sun. So first in the morning twilight, then in the evening twilight, or vice versa. But modern space telescopes can observe that occasionally a comet does not occur at the other side because it really falls into the sun. This was in 2011, when the SOHO spacecraft, a solar telescope, where the sun is covered here in the center, it's indicated by the white ring, and the comet falls into the sun, and then there is an eruption, which is not related to the comet, but occasionally, by chance, happened almost at the same time. But it looks as if the sun would eat the comet. Another comet, 2 months later in the same year, in 2011, comet Lovejoy, one of the Lovejoy comets, was also going towards the sun, and all astronomers already expected that it will fall into the sun. But then the SOHO spacecraft observed that the comet reappears on the other side, but without the tail. So then the press release, the press headline was that the sun just sucked at the comet and then spit it out like a stone of a cherry. So things like this really happen, but does this really nourish the sun? So in most cases, the comets do not really fall into the sun, but make an arc around them, around the sun. They approach the sun and then reappear at the other side, which is normally the case for most of the comets. So apparently, the cosmos, any god or deity did not make the comets to just throw them into the sun. And today we know from space telescopes and space probes, like this, real images of the ESA Rosetta mission, a space mission towards a comet, that shows that comets are indeed not something like gas or something like that. They are solid bodies, at least when they are far away from the sun. And actually, we know that they are something like dirty snowballs, really dirty snowballs. And everybody knows when a snowball comes too close to the sun, or the sun becomes too strong, then the snow melts. And in this case, for these snowballs in space, something else happens. The sun in space is that strong that the whole system, the whole object, not only melts, but sublimates. So it directly goes from the solid state to vapor, which can be seen here in a very warm spring morning this year in April. I had some frost on my on the balcony, on the fence of my balcony. There was some frost in the morning at the wood, and when the sun was rising, it was so strong. The April sun was so strong that the frost directly went into vapor. They directly became gases, so it did not become liquid before. And this process of sublimation, of directly becoming vapor from solid state to vapor, is also observed for comets. So in comets, we have something like that. The frozen gases become vapor immediately, and they also this way they also have some dust, some dirt within this dirty snowball, which is observed like snow or like the dust in churches when the light comes in. Then you see these particles of dust, glittering in the sunshine. This is also what happens to comets. And then something like this is observed also from the ESA mission, the Rosetta mission. But we know that these comets consist of frozen gas and of dirt, of dust. And this is not what nourishes the sun, because the sun actually produces its energy by nuclear fusion of hydrogen in its core. And if anything like a dirty snowball falls into the sun, it actually does nothing. So it doesn't nourish it, it doesn't hurt it, it just falls into it and does nothing. So we know that comets can fall into the sun, but they don't really nourish the sun. But what about the stars? And Seneca says the stars behave similar, and the stars are also nourished by these exhalations and by the material that is produced inside the Earth. Because the stars behave similarly, because the stars, like the sun, also rise in the east, follow their traces above us, surrounding us, and then set in the west, but which can be observed each and every day. Okay, we will skip this here because it doesn't work properly, but you can see that the stars in the night sky also rise in the east and then set in the west, like the sun. But as I said before, the stars and the planets are much further away than Seneca and everybody else expected in antiquity. So they are way further away, and they certainly are not nourished by anything from the Earth or in the vicinity of the Earth, like comets. What they did not know in antiquity, and what we can discover only with modern telescopes, is that there are actually eating stars. Because we have some few stars in the sky which are so close, and which are in multiple systems and so close to each other that they sort of eat each other. Which means, for instance, the sun is a single star. So the sun has some planets orbiting the sun, but there are no other stars in our solar system. Most of the stars that are known by astronomy are not single stars, but are in multiple systems. So there are 2 stars, 3 stars, more than 3 stars orbiting the same gravitational center. And then there is a possibility in some cases where you have 2 stars that orbit each other, that these 2 stars are so close that the outer parts of the atmosphere of one of the 2 components of this double system, of this binary system, that the outer parts of the atmosphere are so close that they are in the gravitational realm of the other star. And then material streams from one star to the other, but it doesn't directly fall into or onto the other star, but it has to spiralize around it, like every water that goes through a sink and then doesn't go directly into the hole in the ground, but spiralizes systematically within the, the bath, in the sink, before it goes out, before it falls down. And something similar happens here. So the material that leaves one of the stars spiralizes around the other star and then makes these beautiful accretion disks. In some cases, these systems are called cataclysmic, specifically if one of the components, the one with the accretion disk around them, is not a real star anymore, like the sun, but sort of a corpse of a star, a remain of a star that is already dead. And these remains or corpse of stars are actually solid bodies. They are like huge Earth-sized diamonds, and we call them white dwarfs. And as these white dwarfs are solid bodies and not gas plasma balls anymore, the gas that is accreted from the other star, that flows over from the other star, cannot go into it because it's a solid body, like a table. So the gas cannot go into that solid body and is pressed together is squeezed together at the surface of this solid body. So with a lot of time, after centuries, millennia, or longer time scales, we don't know, with time, there will be a very high pressure at the surface of these white dwarf stars. And occasionally, there will be some little explosions because of this high pressure. And there will be an explosion here and then occasionally, and sometimes occasionally, the whole surface of the solid body of the white dwarf will burn. And this is then called a so-called classical nova eruption. And this nova eruption will flare up the whole system. And this is really observed in nature. Space telescopes and ground-bound telescopes can observe these eruptions. Actually, we do observe them since, say, 400 years, more or less systematically. But real survey programs to really study each and every system, star and stellar system within a specific field are only underway, are only taken since, say, 25 years or so, maybe half of a century. And one of these survey programs is the Polish OGLE survey that observes only a specific field in the southern Milky Way, and only this field is observed, and each and every star in this specific field is measured each and every minute during the survey. So they observe the brightness, fluctuations, variabilities of all these stars in this specific field. And the OGLE survey in 2016 made or published this paper saying that there was an eruption of one of the stars here, so a very bright eruption. And then they continued the observation and traced it back. So after decline, there was only this pale blue star remaining. And this region here was totally inactive 10 years earlier. So then they went into their own archives and observed that 10 years before the eruption, actually, they could not detect anything here, as if there has not been anything, but there has been something, because occasionally then, a few years later, they observed some eruptions. So out of nothing, there was a dark place here 10 years earlier. And then after a couple of years, some of these minor eruptions were observed, not really registered, but because no star was known here, but they traced it back to this system. So this was only the peak of tiny eruptions. Then there was a huge eruption, and as predicted by theory, the remaining object had the post-nova star had the same brightness as the peak of the dwarf novae before. So this is really observable within the time scale of modern telescope surveys. And here we have a wonderful, beautifully purple X-ray nebula, which is observed now with X-ray telescopes, with space telescopes. But we know that the central star from which this X-ray nebula emerged really erupted in 1901. So we know at roughly 120 years ago, when nobody had understood how a star works and how stars get their energy. At this time, astronomers observed this star flaring up for a couple of weeks, and they observed this classical nova eruption and how the system then declined and vanished into invisibility. But now modern space telescopes can observe a nebula at that place. So we know that these nova eruptions also happened before we had telescope surveys that were able to trace the whole light curve. Are there observations like this from antiquity? Actually, we don't really know. There are some observations that point towards such a direction. For instance, Pliny, in his natural history, says that Hipparchus, the famous astronomer Hipparchus, made a star catalogue, and he did so because he observed a new star that was produced in his own age, and he couldn't prove it that this star was really new. And then because there have been no archives, no star catalogs, systematic observations before Hipparchus. So he started to make a star catalog in order to enable future astronomers to really spot new stars if they occur. So in Greco-Roman antiquity, we do not really have systematic observations of this type. But in the Chinese astronomy, we do, because the Chinese astrology, so to speak, the omens that they derived for their country depended on these flaring up objects, these so-called guest stars. And that is why we do have some guest stars reported from Chinese astronomy, even 2,000 years ago. And they say there was a guest star in the Chinese constellation of Fang. Fang consists only of 4 stars, as indicated here, but we do not have any, not really matching cataclysmic variable system. So we still do not really know what Hipparchus observed at that time, and if the Chinese record really matches the observation of Hipparchus, because Pliny doesn't say where Hipparchus has seen such an object in the sky. Are there other objects in modern astronomy? Yes, of course. Not only stars have accretion disks, but there are also other objects with accretion disks. For instance, most famously, the black holes in the centers of galaxies. The black hole here is a black hole that has been a depiction of a black hole that has been released in 2022 by the Event Horizon Telescope, a European United project, which used several radio telescopes. But even before they released this image of the black hole and its accretion disks, other astronomers had found out that there is a huge black hole in the center of the galaxy, because there are stars in the center of the galaxy that orbit something, and we can trace these stars, and not only stars, but also other objects that are not bound into one spherical shape, like this cloud of gas close to the center of the galaxy, of the black hole in the center of the galaxy. And we know that there are stars orbiting the black hole, and the stars remain stars. So they just orbit the black hole like the planets orbit the sun without falling into the sun. But this gas cloud is distorted when it orbits or comes close to the black hole. It's distorted like the comet that is spit out again by the sun. The cloud of gas is distorted by the black hole, and the black hole sort of eats some of its material, and then it will take several orbits of the cloud until it's completely eaten by the black hole. So actually black holes do eat these clouds of gas and are sort of nourished by them. So the black hole really gets bigger with eating this material, but still they do not eat much. I mean, they do not, eat everything in their vicinity. Only if something comes too close, then they eat this material. There's not only the black hole in the center of our galaxy, but there are several galaxies in the universe, many galaxies in the universe, some looking almost similar to the Milky Way with spiral arms, and also others which do not look similar, which are elliptic giant galaxies. And you probably also have heard about the other photograph of yet another black hole in another galaxy, which is the black hole in the center of the galaxy M87. And here they released an image that was taken with polarized light, and you can really see how the material spiralizes into the black hole. We can also make simulations of all this, and then you can see how the material really goes around the black hole before falling into it. And you see another very interesting optical effect. The accretion disk is really a disk, it's almost flat, and there's some material sort of behind the black hole. But while we are looking at the edge of the disk, then the other parts of the disk that are in space are behind the black hole, appear above and below the black hole instead of behind it. So they are not covered by the black hole, but it appears to us as if they were above and below the black hole. This is a known effect, also used in some science fiction movies of the last decade or so. This is a known effect, and it's an optical effect that doesn't say anything. So the material really falls into the black hole. We simply cannot observe it here because the material takes a lot of time to go around the black hole before it falls into it. So most of the material, the material that we can actually see is not nourishing the black hole directly. And this is the effect here is actually a gravitational lens effect, which is also the same as the effect of the foot of a glass of wine, which you can see here. The optical effect is the same. You can see the Babylonian constellation of the lion and the snake here. And if you put the foot of the glass of wine here, then the image is distorted by the glass. And this same optical effect is observed here for the black hole. So with that, we thank you for your attention, and the facts on nourishing the celestial bodies by Seneca in the point of view of modern astronomy.